Hello, PyCon India. It's pretty exciting to be one of the first talks after the keynote. This one is getting pretty technical. It's a bit of a niche topic that I brought for you. The talk is titled Python and PLCs. And of course, the first thing we have to get out of the way is what is a PLC? So I'll cover that real quick before I start the real talk, before I even introduce myself. This is what a PLC looks like. PLCs are basically a class of computing device, just like there are smartphones, laptops, gaming consoles. There's a PLC. It's another type of device that can do computation. And if you spot one in the wild, the easy way to recognize it is that they usually have lots of colorful wires coming out of them, like the one I have here on the screen. The acronym PLC stands for Programmable Logic Controller. And there's actually a piece of trivia that I only learned about quite recently, which is that when PLCs were first invented in the 1960s, they were just called programmable controllers or PCs. And then, of course, in the 1980s, the personal computer became pretty big. People started calling personal computers PCs. And the people working with programmable controllers were like, this doesn't work. They took over our acronym. What are we going to do? Let's rename it. Let's call it Programmable Logic Controller. And that's when the acronym PLC was coined. And an interesting question that gets raised by this story is, where have these PLCs been hiding, considering that they've been around from the 1960s, and you don't really see them like everywhere? And the answer is that they're usually in industrial settings, in factories, for example. For example, you would find these controller boxes in the factory that control individual devices, like this window tinting machine, or here circuit board assembly machines would often have PLCs in them. PLCs also exist in the built environment and infrastructure. Theme parks, for example, the roller coaster and the behavior when it starts and stops, slowing down, speeding up and such, are controlled by PLCs. Sort of more regular everyday life, elevators and escalators often have PLCs in them. And then oil rigs are actually another example that often gets cited, where PLCs are in charge of controlling the flow of material through the various pipes and all the things that are going on an oil rig. The gist of it really is that all these colorful wires coming out of a PLC, they are connected to sensors and actuators. So you would get an electrical signal from a sensor that travels to the PLC. It gets converted to a variable. The programmable logic executes, turning input variables to output variables. And the outputs then get converted back to electrical signals and doing something. For example, if you're in an elevator, you press the button that creates an electrical signal, which would be represented as a Boolean variable in your PLC. Likewise, if you stick your arm into the closing door of an elevator, you break the light curtain, and that becomes a variable after being an electrical signal. And then the logic that would be implemented in the PLC of an elevator would have items like stop closing the door if the light curtain gets broken because somebody jumped through or put their arm in there. And then the output would be the signals that get sent to the motors, or the signal that makes the little bell go ding when you arrive at your destination floor with the elevator. So that's the very basics of PLCs. You know the gist of it. This is enough to understand the rest of this talk. So now we can start the actual talk. I'm going to start with the usual introduction slide. Who am I? My name is Jonas. I am a software and automation engineer, and I work in the biotech industry. So basically, I write software that controls robots that do science. I'm originally from Germany, but I now live in Oakland, California, which means that the current local time as we're doing this talk is 12:55. So my challenge for today is to stay awake until the end of the talk session of this day. And I can't promise that I'll make it, but I'll give my best. All right, so why am I from all the way around the world giving a talk about Python and PLCs today? Well, that's a little bit of a story, but basically, over the past few years, I've started giving talks about factory automation topics at Python conferences. And last year at PyCon US, I gave one like a very high-level introduction to what PLCs are, all the different types that exist, the many different Python libraries you have available for controlling them. And that seemed like an appropriate talk for the audience. Python developers here in the US, at least, don't usually have exposure to industrial automation equipment. So this kind of high-level talk was appropriate. But something really interesting happened once the talk went online on YouTube. suddenly I started getting all these sort of like emails and Twitter messages and LinkedIn messages with people asking very, very specific questions. They were working on PLC projects, they got stuck on something, they used one of the libraries I mentioned and had some specific questions. And after some back and forth, I realized like 90% of those come from India. And the reason for that is that in India, it seems to be somewhat more common for software engineers to also get exposed to some of this equipment like PLCs and robot arms and so on. And even more so, apparently, especially at universities, it's not unusual for students to work on projects that require some software engineering and some kind of sort of automation engineering working with devices like this. So that's how this talk came about. And the plan for today really is, first, and we've already done this, little introduction to what PLCs are. Second, a mini tutorial to go over the very basic steps to get started with your PLC when you're working hands-on with a PLC project where you want to use Python to connect to the PLC. And then the last part is going to be an FAQ, basically, where I try to answer some of the most common questions that I got since I gave the talk last year, and also some of those common stumbling blocks that I experienced in my own work. The slides for this talk are available at the URL that's on your screen. And if you want to contact me, either like right now during the conference or much later, if you watch this talk on YouTube, you can do that. I prefer Twitter or email, but you'll be able to find me on the internet based on my name. Let's dive right in. The first part of the talk is a little mini tutorial, a step-by-step guide. And what we're going to do is that we're going to use the PLC that I've got here in my little home setup to control the traffic light. So we're going to make this traffic light blink using a program that's on the PLC. It's going to blink the red light sort of every second. And then we will use Python to talk to the PLC to change this behavior a little bit. And instead of making it blink red, make it blink yellow and green, and speed up the blinking frequency and slow it down a little bit. And we'll do that in a couple of quick steps. So let's dive right in. Step one. Whenever you're working with a PLC, the first step is to figure out what kind of PLC you're working with. There are many different brands, tens of brands, maybe like 50 that are in active use. Some of them are really big ones. They're dominating the industry, but the others also exist. And each PLC brand works a little bit differently. They have different nomenclature, different numbering schemes, support different protocols. They're just used for different applications. So it is important to first find out what PLC you have and actually read the documentation and training materials that the vendor of the PLC would normally provide. So in my case, I can just check here. The model number of the PLC is P1540, and I purchased it from a manufacturer called Automation Direct, which is just a manufacturer who sells directly to customers here in the US at pretty affordable prices. So I was able to have this here in my home lab without breaking the bank. All right, we figured out what PLC it is. The next step is to create a network connection to the PLC so that you can talk to it from your laptop or server or whatever computer it is that you want to connect to the PLC to. So you've got various options. I said network here. Some PLCs also use a serial port for communication. That's used to be more common in the past, but is still around. I went for Ethernet just because that works easiest for me. So the PLC is wired up to this Netgear router here, which is also connected to my laptop. And I assigned an IP address of 192.168.1.9 to the PLC. Remember that, we'll use that one later. I configured my laptop with a neighboring IP address and set up the subnet mask and all these things. So these two things can talk with each other, and I confirmed that by just pinging it to make sure it works before I started the talk. And then step 3 is to program the PLC. Remember, these things are programmable logic controllers. So when they arrive from the manufacturer, they do nothing. Just like when your laptop arrives at the start, it does nothing. You have to put the program on there and define its behavior. The way you do this is you have to use the vendor software. Most PLCs, you have like one specific software provided by the vendor to program this specific kind of PLC. Sometimes there are 2 options, but that's about it. It's not like when programming Python where you just freely get to pick your editor. And I'm going to show you real quick the program that I've already put on there. But first, a word of warning. when I switch over to the PLC programming software, you will see a non-Python language. If that's too much for today, just close your eyes for 2 minutes and then we'll come back to the slides. But the language that we're going to look at is pretty cool. It's called ladder logic. It's a graphical programming language, extremely common in the world of PLCs. And I use it in this example, but I don't really expect you to understand the language. I just want to highlight a couple of specific points that are important for the subsequent steps. So let's switch over to the PLC programming software. And this is the program. So the ladder logic program here, the first line of it, note that there's a variable called the blink interval milliseconds, which defines the blinking interval of the traffic light as it's going to start blinking. And it gets scaled to by some internal factor, doesn't matter. Lines 2 and 3 are two timers that just define the time that the traffic light is on during blinking and then the time that it's off. And the fourth line here uses a variable called blink color. And if blink color equals 1, it's going to blink in red. If blink color equals 2, it's going to blink in yellow. And if it's 3, it's going to blink in green. And I'm just actually going to switch the PLC on now to start running. And this program is already on it. So the blink color variable is set to 1. So that's blinking in red. And the interval is 1 second on, 1 second off. So the variable blink interval millisecond must be set to 1000 for the 1 second blinking interval. And that's basically the program on here. So yeah, steps 1 to 3, I should mention, often those are just information gathering tasks. Usually you as the software engineer, you're not responsible for purchasing the PLC and wiring it to the network and programming it. In most situations, and there has been an automation engineer or somebody else who has already done this. If you're at work, you would usually show up to a customer or within your own company to the factory floor where the PLCs are already installed. Even if you're part of a project that installs a new PLC, most companies have a specific brand that they always purchase from, so you don't get to pick from the wide selection of PLCs available in the world. And most often somebody else has, like I said, already developed a PLC program to control the factory or the piece of equipment you're working with. Your job is really to interface with it, which is what we're starting to do in step 4. Step 4 is to assign the PLC program variables to Modbus registers. And there's a new word here, right? It's Modbus. Modbus is a technique and a protocol that is almost as old as PLCs themselves. And it's a way for the PLC to share the content of the variables it's using in its ladder logic program with the outside world over the network. So you can basically imagine that one part of what the PLC processor is doing is to execute this ladder logic program and making the traffic light blink. And then the other half of the PLC processor, in modern PLCs, it's usually a different processor core, handles the network traffic and interacts with the outside world. And one thing that we can make this part of the PLC do is to maintain basically a long list of registers, or you can think of it maybe as shared memory, where the variables that the PLC is using are available. So the PLC internally moves this over to the, let's call it shared memory, and then other devices on the network can use the Modbus protocol to read what's in the shared memory, but also to write it. And that's basically how the Modbus protocol works, which we are running over the Ethernet cable today. And the terminology in Modbus is, the laptop is the master and the PLC is the slave. It's a protocol from the 60s. So back then it was cool to use this kind of terminology in your protocol. I would call the laptop a client since it connects to the PLC and sends and receives values from it. So the PLC acting as a server. Modbus, like I said, very old protocol, so they didn't use terminology like Boolean and floating point and such for their variable types. You call it coil and holding register. Doesn't really matter details. The point is we are trying to access two numbers, right? We want to change the color it's blinking in, which is a number 1, 2, or 3, and we want to change the frequency, which is a number that's sort of in the thousands. So we definitely need the 16 bits data type that it's got available for us, and not the 1-bit one. And we want to write it. So that means we're going to have to deal with holding registers as opposed to coils and any of the other things. The two holding registers we're going to use is the first one, we want to put the blink color in. So we're going to put this into the first holding register available, which has Modbus address 1 in this 40,000 range of addresses. And in Python, because Python is 0 indexed, it's going to be index 0. Then second example, the blink interval in milliseconds that we're going to change is going to be in the second holding register. So the Modbus address is 2 in the 40,000 range, and the Python index, again, Python being 0 indexed, is 1 for the second holding register. So keep those two things in mind. These are the Modbus addresses we use to share those variables. In fact, we have to set this up now. So let's go over here. In this programming software, there is a list of all the variables that exist in the program. And right here at the top of the list is blink color and blink interval millisecond. And I'm actually going to go right in here and use the default values that the software gives me to assign those addresses. So like I said, we're going to have the blink color in the first Modbus holding register, so the 40,000 range, which in this software for mysterious reasons, the 400,000 range, it's going to be 1. And then the blink interval millisecond variable is in the register 2. So we're going to close this, and we actually have to send this new information, the fact that we want to expose those to the PLC. So this is me programming the PLC to have this, to actually expose those variables as Modbus registers over the network. And that's done. It starts blinking again. Good. So we're ready for step 5. We're now going to use a Modbus protocol implementation in Python to start reading and writing those registers that we just made the PLC publish to the network. This is a full list of the sort of the actively maintained implementations of the Modbus protocol that exist in Python. The most popular one is PyModbus, very well maintained library, very popular. I decided to choose a different one because it has a slightly simpler API and nice debug output, which makes the demo here better. But all the ones on here are good options. Of course, depending on whether you use TCP over Ethernet or a serial connection, certain ones support either one and not the other. And if you decide to switch the roles of the Modbus protocol, and which you can do, and make your laptop act as the server device or the slave device with the PLC the other, you also might have only a subset of the available options. Just to draw your attention to the bottom of the list, the second from the bottom is a MicroPython implementation of Modbus, which is interesting for anyone who uses Python to program microcontrollers. I just wanted to call this out, even though that's actually not a PyPI package. You have to download that straight from source. So we're going to pip install PyModbus TCP. That's the one I picked for this demo. And then we're going to use some Python to actually talk to the PLC. I have a minute, so I'm going to do this as a live demo. So pip install PyModbus TCP. I've already installed it, so it's going to tell me already satisfied. I'm opening a Python shell. And in here, we're going to import this library, use the Modbus client class, and create a client. Now, this is where we have to specify the IP address of my PLC that I told you earlier. And then I'm actually going to set just 2 flags that make the demo flow a little more cleanly. So this is a client. So now first, what are we going to do? First, we read from the PLC what the variable value of the blink color is. And it should be 1 because it's blinking in red. So read holding registers. And we want to know the first one, which is Python index 0. So you can see this is the Modbus protocol, the sending and receiving. It's a very simple protocol, so just a couple of bytes. And then it tells us this variable is indeed 1. And now I'm going to say, well, let's change it. So I want to change a single register. I want to change the first one, and I want to set it to value, let's say 2, and make it blink in yellow. So using Python, we now changed the value of the variable in the PLC, and it immediately started using the new value, and it's blinking in yellow now. And of course, you can also set it to 3, and then it's going to start blinking in green. And I'm going to go make it go back to red. And you can also change the other variable. Remember, in the second Modbus register that we made available over the network, that's where the blink interval in milliseconds is. So it's currently at 1,000, and I'm going to make it blink twice as fast. And there we go. Now it's only on for half a second, then off for half a second. I gotta say that makes me nervous, so I'm going to slow that way down to every 2 seconds. Great. That's basically it. That was the demo part of this talk. Those 6 steps, they could apply to any other projects. I used a traffic signal with 2 relatively simple variables. But any program that you have on the PLC, you can expose variables as Modbus registers and then start interacting with them. So you should be able to apply the same kind of concepts to your project, even if you're using a different kind of PLC or have a very different program on there. Let's stop this so that it stops blinking here. On to part 2. Got 5 minutes to quickly run through a couple of questions that commonly come up when you do this. The first one being, do we have to do all this stuff with like ladder logic? Can't we just program the PLC in Python? And the short answer is no. The long answer, there are 2 options. There's the easy, sort of the excuse kind of answer, where I could say, well, what a PLC is defined in an international standard called IEC 61131. And that lists the languages that you should be able to use to program a PLC, and Python's not on there. But that's a bit of a lame answer because we could break the rules, right? The reason Python is not on this list of languages, though, is that PLCs have a very specific job. They're supposed to execute the code in real time. Now, real time, people often misunderstand as being fast. That's actually not what it is. Real time means it's predictable. So every time the PLC executes this ladder logic code, it's doing it in the exact same timing. And there are very tight limits around how fast it needs to go. The effect of this is that when I stick my arm into the elevator door, it can't happen that, because the PLC is just networking, installing some updates or something, it takes a second until the door stops moving and is crushing my arm. That would be unacceptable. There are safety implications of this. And that's the reason why we use PLCs and why we have to program them in languages that support this real-time execution. Now, I'm not saying that with some wizardry, you couldn't make Python execute in real time. It might be possible, but Python is just not a language designed for this purpose, which is why programming a PLC in Python just doesn't really make sense. In fact, I like to think of the role that Python plays when interacting with PLCs as that there are 2 control loops. There's the inner control loop, which is running a ladder logic on the PLC, which very quickly at sort of the millisecond clock cycle deals with electrical signals. It interacts with the physical world. It takes care of the timing critical and safety critical logic. And then there's this outer control loop, which might be running in Python, which just changes some of the process parameters of the inner loop. And the reason you might use Python here is that maybe you want to tap into other parts of the PyCon ecosystem, such as doing some kind of machine learning or artificial intelligence logic to figure out, how fast to blink the traffic signal or whatever else it is that your process parameters control. As a matter of fact, we did reading and writing of those process parameters. The much more common case, which is called IIoT, the Industrial Internet of Things, or Industry 4.0, is really only concerned with reading those values and storing them in databases and analyzing them and maybe doing machine condition monitoring. So when you come across those buzzwords, IoT and so on, that's what that is about. It's basically a matter of reading the value of variables that are already existent in your PLC. Second question, is Modbus the only PLC communication protocol? It's actually not. It was the first protocol invented for this purpose. It's still very popular because it's very simple. It's actually also very unsafe. That goes hand in hand with being very simple. So there are no security mechanisms like authentication involved. There's a whole range of other protocols. There's a Wikipedia link on the slide. I think on there is something like 100 different protocols. Some of them you can use on your laptop over a regular Ethernet hardware, and some others have traits that require specialized networking hardware. The ones in the former category usually have a Python implementation available. Just type the name of the protocol into the PyPI search and the package will pop up. Next question, help, my Python script won't connect to the PLC. Well, that is quite possible, and it highlights that many problems you encounter when working with PLCs are in fact networking problems. So please make sure to know the basics of networking. How do IP addresses work? What ports are involved in the protocol you're using? How are subnet masks working? Be familiar with the firewall and antivirus settings, because those things often get in the way. And keep in mind that your PLC might not actually be on the network at all, because that is a common way to keep these things secure from hackers, to just not connect them. So even if they're plugged into the same router, maybe the router is configured to not pass any traffic between your laptop and the industrial control network. So these are things to keep in mind when you can't even get started with your project. Next question is, why don't we just use a Raspberry Pi or Arduino for controlling these electrical outputs? I can make a light blink with a Raspberry Pi in 5 minutes, many people say. And that's true. The big difference between Raspberry Pis and Arduinos, Raspberry Pis and PLCs, is that PLCs are designed for those environments like factories and oil rigs and so on, and your Raspberry Pi would probably die in them. So besides not necessarily satisfying the real-time characteristics, it also doesn't have the right kind of power supply. It doesn't, it doesn't do well in hazardous environments. You can make a Raspberry Pi into a PLC by adding these additional features, and there are projects and even companies out there doing this. But the end result is that you have something, once you made all the changes, your Raspberry Pi looks like a PLC again and also has a similar price. So there's really not much of a point of doing that. Maybe you want to get started with working on PLCs, but you don't want to purchase an expensive piece of industrial equipment. And there are several options available for that to simulate the PLC, starting with actually using the Python libraries we just looked at to simulate the behavior of a PLC, to slightly more sophisticated options. I put them all on the slide. I'm actually not super familiar with all of those, but in case you're interested in doing this, please take a screenshot and go for those. I've heard good things about all those options. Finally, you might be wondering, hey, Jonas, can you help me with my PLC question? So first of all, I'm not really a super expert on PLCs. I just happen to tinker with using Python to talk with them. But if you send an email to me or anyone, or you're just looking for help on the internet in a forum, or maybe just even trying to search on Google, here's a couple of things you should always include when asking your questions so that the other person can help you efficiently. As I already mentioned, every brand of PLC is different. Make sure to include the brand and model name of your PLC. Mention what programming software you use, what communication protocol you're working with, and maybe even include a Python snippet that illustrates what you're trying to do. Finally, if your environment allows it, please include a sketch or even a photo of the setup that you're working with, because often that makes it much more clear what it is you're trying to do. Of course, don't do that if this is for your work and it's confidential information. In that case, skip the photo. That brings me to the end of my talk. This is my last slide. Just a reminder, these slides are available online. And I didn't leave any time for questions here in this talk, but you're welcome to contact me using the contact methods listed on this slide. Thank you very much.